Welcome back, everybody. In this video, we are going to be examining trigonometric coordinates. We'll talk about converting back and forth between trigonometric and rectangular form, and you're going to get your first tiny introduction to the thinking behind inverse trig. We're going to look at trigonometric coordinates, and to understand what trigonometric coordinates are, you want to think of a point P that's located somewhere on the coordinate plane. P has some xy coordinates, which we generally refer to as the rectangular coordinates. And by rectangular, I mean the coordinates that you've been using up to this point in your math career. So like 2, 3 would be rectangular coordinates. We want to be able to convert those into trigonometric form. To help visualize that, you should think of the point P as being on a circle centered at the origin. I just brought in my circle there. And we want to pretend that P is located r units from the origin. So I'll draw a line. That's r units on the terminal side of an angle theta. So we'll draw in our angle theta there. And so our goal now is to express the xy coordinates in terms of sine and cosine. So I'm going to draw a right triangle around that angle theta with r as its hypotenuse. And so now we know that the opposite side of the angle theta is going to be equal to the y coordinate, and the adjacent side will be equal to the x coordinate. And what we could do now is we could take the sine of theta. The sine of theta is going to be equal to the opposite of our hypotenuse side, so it's going to be y over r, and the cosine of theta is the adjacent over hypotenuse side, so it's x over r. And once we have those, we could solve for y and x, so I'll multiply by r on both sides. The r's cancel, and we get that y is equal to r sine theta, and x is equal to r cosine theta. And so our trigonometric coordinates are r cosine theta as where our x coordinate would go, and then r sine theta where our y coordinate would go. So let's look at a few examples with that. This first example is asking us to find the trig coordinates of a point P that is located 3 units from the origin on the terminal side of an angle in standard position with angle measure 5 pi over 6. I'm going to do a quick sketch of what we're looking at here. We're asked to find the trigonometric coordinates, so we know that r in this case is going to be 3. Theta is equal to 5 pi over 6, which means our trig coordinates are going to be 3 cosine of 5 pi over 6, 3 sine 5 pi over 6. And since another example you might see is something asking you to find the rectangular coordinates of a point when you're given the distance from the origin to that point, that's what OP means, and the angle itself. So again, we'll sketch out a quick XY coordinate plane for ourselves. Sketch in our angle, which is 150 degrees. Our point P is a distance of 10 away from the origin, so this segment right here would be 10. And so that means our trigonometric coordinates would be 10 cosine 150, 10 sine of 150. But we want rectangular coordinates, so we're going to actually have to evaluate each of these trig functions and simplify. So to evaluate, remember that our reference angle is 30 degrees. The angle terminates in quadrant 2. So that means that cosine is going to be equal to negative cosine of 30. And sine is going to be equal to positive sine of 30. Cosine of 30 is the square root of 3 over 2, so we get negative 10 times the square root of 3 over 2. And then 10 times the sine of 30 is 1/2. And we simplify that to negative 5 square root of 3, 5. And so those are the rectangular coordinates. Again, rectangular coordinates are what we're used to working with. It's a lot easier for us to work with them just because our minds understand the quantity negative 5 square root of 3 and 5 a little bit more than they do something like 10 cosine 150, just because we've been graphing with that Cartesian xy coordinate plane for our whole lives. Another example I'd like to look at is finding the sine, cosine, or any other trig function if you are given the rectangular coordinate. So again, we're going to go ahead and sketch this out. Whoops. So we've got our xy coordinate plane. We're at -2, +4. We want the sine, cosine, and secant. This is pretty similar to things that we've done before. We can sketch in a little right triangle there. We know that's going to have sides of 2 and 4. And so we're looking for the hypotenuse side, which we can call c. So 2 squared plus 4 squared equals c squared. We get that 20 is equal to c squared. So c equals the square root of 20, which will simplify down to 2 square root of 5. And we know that cosine will be x over r, and r is our c value right here, that's r. And sine will be y over r, sine of theta will be y over r. So cosine equals -2 over 2 square root of 5. Sine is going to be equal to 4 over 2 square root of 5. And when we rationalize those and simplify them, we get -1 over the square root of 5, which gets us that cosine of theta, after we rationalize that, is the negative square root of 5 over 5. Sine of theta will simplify to 2 square root of 5 over 5. And we know that secant is the reciprocal of cosine. So secant, if we go to our original ratio that we got for cosine, we could just flip that, or even better, we can go to -1 over square root of 5. We'll flip that and we'll get the negative square root of 5 over 1, which is just negative square root of 5. So there you go, you can get the reciprocal trig functions as well. Now last but not least, we're going to find the trig coordinates given rectangular coordinates. And we have to do some thinking for this one. So again, we're going to sketch out those coordinates on an xy coordinate plane. And so our point P is right there in the third quadrant. To get a sense of where -4 radical 3 is, you could just plug that into your calculator. It's about -6.9. So this is round about -7 is where I placed that y coordinate. Now we're looking for the trig coordinates. So what I'm going to do is I'm going to draw on an angle, because we know the trig coordinates will have an angle theta in them. And I know that this part of theta that I'm going to highlight in red is 180 degrees. So really what I'm looking for is this angle right here, which we would almost think of as a reference angle. I'll call it alpha, which is that almost fish looking symbol. And to figure out what alpha is, I'm going to draw a separate triangle with alpha in it. I could draw it upside down if I want to, that's fine. So I know that the opposite side of alpha is going to be 4 square root of 3. The adjacent side of alpha will be the same magnitude as our x coordinate, so that's going to be 4. Again, I'll draw in the x coordinate, so -4, -4 rad 3. Now we're trying to figure out what that angle alpha is, and this is like a little bit of a precursor to inverse trig functions. So what we could do is we could set up a ratio. We've got the opposite side and the adjacent side. I'm going to set up tan of alpha equals opposite, which is 4 rad 3, of the adjacent, which is 4. That simplifies to tan of theta equals the square root of 3. Now all we need to do is go back to our heart chart and figure out which angle it gives us as a tangent ratio of square root of 3. That angle would have to be 60 degrees. And so theta is going to be equal to 180, which is that distance I highlighted in red, plus that 60 degrees, which is 240 degrees. And now that we have theta, all we need to do is figure out r, which is that distance from the origin to the point. R will be the hypotenuse of our right triangle that we drew there, so we could use the Pythagorean theorem to solve. And so when we solve out, we get that r value is equal to 8. And so we're good to go. So our trig coordinates are r cosine theta, so 8 cosine 240, and 8 sine of 240.